Jai Hind everyone. I am Achintya Pandey, as Assistant Professor in the Department of Information Technology at Ajay Kumar Garg Engineering College. Today I will discuss flow control techniques, what is flow control and all in computer networks. Okay. So to explore the flow control. So what is flow control? In my last video, I have discussed OSI model and TCP/IP model, right? Of communication between two systems. What could be the standard? So we have discussed there are 7 layers. Okay, one is physical layer, second is data link layer, third is one is network layer, fourth transport, then presentation session and application layer. Okay, so every layer provides some sorts of service, and the below layer use it. Okay, flow control, error control, and framing. This is provided by the data link layer, second layer, and even at the transport layer. Okay, so what is flow control? Let's discuss what is flow. Flow control means if say sender wants to communicate with receiver, or suppose like this is a system, this is another system. Okay, this wants to communicate with B. If flow control is basically a technique to control the flow of the data. Flow of data means, suppose if there is a mismatch between the speed of flow of speed of data. Okay, like if sender, suppose this is the sender, right? This is sender. Sender has more speed to send the data to B, and if the receiver, say B here, is having lesser speed as comparison to sending speed, so what will be the problem? The problem will B will have so many, many packets, okay, and they would discard it, okay, because if A has more speed and this has less speed to receive the packets or frame or data, okay, so this has there will definitely be a queue, waiting queue, okay, and due to waiting queue, B would have to wait, okay, so dropping up packets and all will be there. So if there is a mismatch of speeds, okay, so this is a problem, and packet could be lost, frame could be lost, data could be lost. So there must be some technique which control the flow of data. Okay, so how we will overcome? So there are basically the technique which is used to control the flow of data are mainly stop and wait protocol and sliding window protocol, right? Okay, so we'll let's discuss flow and error control. This is the job of basically at the data link layer. Okay, so just you can see the most important responsibility of the data link layer are flow control, error control, and this is collectively called as a data link control also. So data link control means flow as well as error. Error means while sending the data, the bit may change from 0 to 1 or 1 to 0. So there may be error. Okay, so error must also be removed. Oh, so this is some another techniques. We have so many techniques, checksum, CRC and all that. Here in this lecture, we will try to focus just on the flow control. Okay. So this is the definitions. Flow control refers to a set of procedure used to restrict, okay, the amount of data that the sender can send before waiting for acknowledgement. Okay. So how the sender could restrict? Why it would restrict? Because receiver is slower as comparison to sender. So if one is faster, second one is slower, so there will be mismatch, and then how to synchronize this could be done by this technique. Okay. Similarly, error control in the data link layer is based on automatic repeat requests. This is not so the data link layer can combine framing, flow control and error control to achieve the delivery of data from one node to another. Okay, the protocol are normally implemented. This technique, I mean flow control, error control, are basically implemented in software by program. Okay, so there are some algorithms which ensure that there must be flow control or error controls. Okay, so we can categorize the protocol, flow control protocol. We will mainly discuss flow control. Okay, so flow control protocol, this could be for noiseless channel and it could be for noisy channel. Okay, so mainly the protocol is stop and wait protocol and sliding window protocol. This go back and selective repeat, these all comes under sliding window protocol. So just see for the noiseless channel, one is simplest protocol, how we can control the flow. Okay, and one is stop and wait. So let's see one by one. For noisy channel, it is stop and wait ARQ, go back and ARQ, and selective repeat ARQ. ARQ means automatic repeated request. Okay, so noiseless channel. Let's first assume that we have an ideal channel in which no frame are lost, duplicated, or corrupted. So we introduce two protocols for this type of channel. One is simplest and second one is stop and wait. So you can see that from upper layer, say network layer, data comes, and then from data link layer is come a frame, and frame over the network at the center side. Similarly, the receiver, this frame could be received by the data link, and this layer has the responsibility to control the flow of the data. So it is implemented in the software. So this software, this program ensures flow control technique ensures that there must be synchronization between the speeds. Okay, so we will see following figure shows an example of communication using this protocol, and let's see the example. We can see this is sender A, sender B. Data at the data link layer is called frame. So here data is just as a frame, because flow control technique will be implemented in at data link layer. Okay, so here data will be as a frame. At network layer, what is data? It is called packet. Okay, so you can see that sender A send one frame, it is been received, then sender send another frame, and so on. Okay, so packet or frame been received. Okay, so this is very simplest, you can say. Okay, now what is stop and wait protocol? Stop and wait means sender send the frame, okay, and it wait until it is acknowledged by the receiver that frame has been received or not. Okay, sender can send frame, and this could be possible that the frame may be lost in the network. Okay, so if a frame is lost in the network, receiver cannot receive. So how it ensure that the frame been received or not? This frame, the lost frame, for whatever the reason, must be retransmitted. So how we will discuss how this type of problem could be solved. So we will see. So in stop and wait, as the name suggests, stop and wait. So sender will not send the next frame until it is until the acknowledgement of the previous frame is received. Okay, by you can, like here, this is the flow diagram. For example, see, stop and wait means sender will stop sending another frame until unless the acknowledgement of the previous frame is not received. This is the sense. This is the meaning of stop and wait protocol. Okay, for example, A is sending a frame, B has received. Okay, so from receiver a ACK message comes to the sender. So during the time, I mean during this much time, this is the time frame, the moment frame has been sent, okay, and the ACK received, this much time sender has to wait for every frame. Okay, sender cannot send another frame until the ACK of just previous frame is received. So that is the concept, or that is the idea of stop and wait protocol. Sender has to stop, sender has to wait, okay, until unless the ACK of the previous frame is not received. So then of course if we will use this much frame, so every time the sender would have a significant amount of waiting will be there. So the channel efficiency or utilization will be quite low. Okay, but this is the concept. If ACK is not received, or suppose if frame is lost, or if frame is lost, then what sender would do? It would never receive ACK. So if frame is lost, every frame, another point is there is a timer with every frame. Okay, there is a timer with every frame. Every frame is attached with a timer. Once the timer of frame is over, then if during the time of the frame it has been not received, then sender will retransmit the frame. So either the frame is lost or even ACK is lost. In both cases, what sender will do, when the timer of this particular frame is over, it will retransmit. If it is received, then it is already okay. But if any particular frame which is not received by the receiver, there could be two cases. Either frame is lost or either ACK is lost. So either frame is lost or even ACK is lost. It has been not received by the receiver. Okay. So the moment the timer of this particular frame goes off, okay, sender would retransmit. So by this way, every frame gets transmitted, but a significant amount of waiting is considerable in the sender. So utilization definitely is the channel utilization and all will be very slow. Okay. So to overcome, there is another technique that is called sliding window protocol, in which sender would not wait. Sender, there is a window and sender continuously send the frame without receiving the ACK. In stop and wait, the moment it receive ACK, okay, then it send. But in next technique, we will see that without receiving ACK, sender starts sending some frames, and once the ACK comes, okay, then the that particular window slides. Okay, so this is the way, and you can find channel utilization, transmission time, and all by the formula. Like what is channel utilization? Channel utilization, active time of sender divided by total time. Okay, active time is transmission time. Total time is transmission time TT plus twice TP, propagation delay, double of propagation delay, because frame, this is the TP from A to B, propagation delay, and receiving this ACK same time will be there. So TT and 2TP. So TT divided by TT plus 2P. If you want to calculate the channel utilization U, then this will be TT transmission time divided by TT plus twice TP. This will be the channel utilization, which is quite less in case of stop and wait protocol. Okay. So the next technique which we will see, that is a sliding window. So this utilization will be all exactly increased by W times, which is the window size. Okay, that we will see. Okay. So now, although the stop and wait protocol gives an idea of how to add flow control to its predecessor, noiseless channel are non-existent. Of course, the channel, it is not possible that channel will be noiseless. Okay, in practical, channel will be noisy. Okay, error control we did not consider in this. So in stop and wait ARQ, we use sequence number. If the channel are noisy, so we use sequence number. Okay, to number the frames. How we'll number the frame, like 0 frame, 1 frame and all. Okay. The sequence number are based on modulo 2 arithmetic. Okay. Modulo 2 arithmetic means remainder when divided by 2. So you can start numbering the frame by 0 or 1. Okay. So in stop and wait ARQ, the acknowledgement number always announced in modulo 2 arithmetic the sequence number of the next frame expected. This is you can design of, you can say, stop and wait ARQ. The numbering will be, because any thing which is divided by 2, you can get any number divided by 2, the remainder will be 0 or 1. So in this scenario, in this fashion, frame as numbered like 0, 1, 0, 1, 0 first, then next one, then 0 next, and all that. Okay. Okay. Following to so and stop and ARQ means automatic repeated request. So for noisy channel means practically. Okay, practically transmissions. Practically means frame could be lost, ACK could be lost. Like already discussed. Say this is the frame, first frame 0. Okay, it is here, I mean received. So frame been arrived, and ACK 1. We always number ACK for the next, not ACK 0. ACK 1 means you can send the first next frame. Acknowledgement numbering is always numbered as next. So ACK 1. Now this 1 means one frame 1, say been sent by the sender, but during the transmission or in between, this frame is lost. So what we'll do? So with this frame, once the timer of this frame 1 goes off, then it will retransmit. So say this is the timer of this frame, this much is the timer of frame, it goes off, again it is resend, and this ACK 0 means of next frame, 0th one. Okay, then frame is next frame is being sent. Similarly, say not frame is lost, but ACK is lost. In that case also, what we'll do, once the timer of this frame goes off, like if this is the time reference. Okay, so when the timer goes off, this has been reset. Okay, so either for noisy or noiseless channel. For noisy channel, what we are adopting, either frame being discarded, either frame is lost in the network or ACK is lost. In both cases, when the timer of that particular frame is goes off or just goes off, it will mean retransmitted. So by this way, things are done. Now we will discuss. So we have discussed stop and wait. So basic idea of stop and wait flow control is, sender will not send the frame until unless it received the ACK of its previous frame. Sender has to wait. Sender has to stop sending frame. Okay, and wait till ACK of the previous frame received. But by doing, if we implement a stop and wait protocol, then utilization cannot be increased much. Okay, so there is another algorithm, and that is called sliding window. In sliding window, there is a concept of window. Window consists of not just one frame, but it could have so many frames, and up to the size of window, the frame without waiting for the next, without waiting for the ACK, it can send. Okay, so that much efficiency will be that increase. Okay, so that is the idea. Okay. And once the ACK of any particular in between frame receive, the window slide by that. Okay, suppose we have set numbering like 0, 1, 2, 3, 4 like that. Okay, and once the ACK of ACK2 receive 0, 1, 2 means 3 frame has been received. Okay, so window will slide by 3. Okay, so window, so in the next and all that received. Okay, now this sliding window protocol is categorized into two categories. One is go back NARQ and second in selective repeat ARQ. Okay. So in go back N protocol, the sequence number are modulo 2 to the power m, where m is the size of the sequence number. Suppose if the size of sequence number is 3, so there could be 2 to the power 3, means 8 total sequence number could be generated. Okay. So you can see the send window is an abstract concept defining an like this. So in go back NARQ, the window size will be 1 less by 2 to the power m. 2 to the power m minus 1 will be the window size. Okay. And this is the behavior. Just see the example. The receiver window size will be 1 always. Okay. See from here. Window size for go back NARQ. Okay. Window size will always be less than 2 to the power m. In go back NARQ, if m is the bit to represent, sequence number. Okay. So the size of window will be 2 to the power m minus 1. Okay. So like here 0, 1, 2, 3. Suppose 2 bit is used for sequence number. So by using 2 bit, how many sequence could be generated? 2 to the power 2, that is 4. Okay. So 4 sequence number, and you can numbering this 4 sequence number as say 0, 1, 2 and 3. Okay. Now if we are using the sliding window protocol as a go back NARQ. Okay. So in go back, the window size will be 2 to the power n minus 1. So here 2 to the power n is what? 4. So 4 minus 1 is equal to 3. It could not be equal to 2 to the power m. Okay. So here window size will be 3. So what is the meaning of 3? 3 means frame without getting, a CK of 0, 1 or 2, 3 frame at a time could be sent. Okay. So there should not be any wait. So by that it increase, it increase the efficiency, or you can say utilization. So in go back and ARQ, the size of the send window must be less than 2 to the power m. The size of the receiver window is always 1. So you can see like here figure flow diagram of example. This is what frame 0 ACK received, and this is for loss. Following figure shows. Just wait. Okay. So no way. Go back NARQ. What we are doing in go back NARQ, like already discussed, if window size W will be less than 2 to 1, 2 to power less 2 to power n minus 1. Okay, this will be the less by 1. Okay. So means what? Suppose this is the sender and this is the receiver, and for example, window size, this is n equal to, say for example 2 or 3. Okay, let's see n equal to 3. 3 means to represent sequence, the bit is the bit requires 3 bit. So using 3 bit, there could be 8 sequence. Okay, 0, 1, 0 to 7, but the window side will be 2 to power n minus 1, means it will be 7. This means 0, 1, 2, 3, 4, 5, 6, 7 frame at a time could be sent without waiting, without receiving the CK of, say, suppose if this is 0, this is 1, 2, 3, then suppose if ACK received of say 4, okay, ACK 4 means what? 0, 1, 2 and 3, 4 frame, it ensures that 4 frame is being received by the receiver. Okay, so window just slide by 4. So from next window, I mean here this will be 3 and this will slide by 4. So in new window, 3 frame of old window and 4 frame from new window comes. So window will always have some frame, and by this way frame is it's ending. Okay. So this is the concept of go back ARQ. And second, suppose in go back ARQ at frame always receive in order. For example, here this is the receiver, this is 0, this is 1, 2, 3. Suppose second frame is, for example, lost, either AKGEC or frame is lost. So the protocol ensure that the out of the order frame will not receive. Okay. So out of the order means here, if say for example frame 2 is lost. Okay. If frame 2 is lost, so this protocol ensured that frame 3, frame 4 will not receive. Okay. So when second frame, which sequence number is say 2, been retransmitted, till the moment no other frame will be received. So basically there are two main things. There are two mainly difference in sliding window protocol. There are two protocol, go back ARQ and selective repeat ARQ. Okay, so they are just two difference. One is window size. In go back ARQ it is 2 to the power n minus 1, and in selective repeat ARQ this is 2 to the power n divided by 2. One is window size, there is a difference of window size, and second one is out of the order frame is never received in go back ARQ. For example, if the frame always will be received by in order. Okay, why this is? Because the receiver window size is 1. Okay, so it cannot receive more than 1. Okay, so the moment it gets out of the order, it just discard. Okay, so when say here if 2 frame whose sequence number is 2 is being lost, so the moment 2 is being retransmitted, when will retransmit? When the timer of 2 frame goes off, it will be retransmitted, then and only 3, 4 and 5 frame will be received. So in go back ARQ, out of the order frame is never received, only in order, I mean ordered frame are received. So this is basic or fundamental difference between go back ARQ and selective repeat ARQ. Okay, and basically stop and wait ARQ is what? Special case of go back ARQ. Okay, so this is all about in selective repeat. It is also sliding window protocol. The difference is window size. In selective repeat, window size is 2 to the power n by 2. Like suppose if n is 3, so 2 to the power n, 2 to the power 3 divided by 2 means 8 by 2, just half. And in go back ARQ, it is just less 1, 2 to the power n minus 1, but here window size is 2 to the power n by 2. And another important difference is in selective repeat ARQ, out of the order frame could also be received. If a frame is damaged, for example, say any particular in between frame is damaged, so this protocol ensure that even out of the order frame comes, it will receive, and the frame which has been damaged, NAK, negative acknowledgement comes, and when the frame, I mean the timer goes off of that particular frame, it is again retransmitted and frame received. Okay, so depending on the type of applications, we can use either go back ARQ or selective repeat ARQ. So this is all about the flow control technique. One is stop and wait protocol, and second one is sliding window protocol. In sliding window protocol, one is go back ARQ and second one is selective repeat ARQ. That's all about.